In a recent video I gave a very brief introduction to this Kunkin KP184 electronic load. I purchased it for a very reasonable price. It's £135 delivered. It's a 400 watt electronic load, 150 volts, 40 amp maximum. It seemed to be performing very well at first test. I've been using it for a while, running various tests on it, and in particular I purchased it to allow me to test these Ryden power supplies that I'm building. I do have a number of electronic loads, but I needed some that I could leave hooked up for fairly long-term testing, and so I needed several low-cost units and decided to test a few, and this was the first one I looked at. On first inspection, if you look at the previous video on this, the internals are quite nicely put together, good quality PCBs, good quality case, brass inserts for the plastic where the screws go into them. Not too bad, and the plastic's reasonable quality. It's the usual cheap type of plastic. Not the worst I've seen, not as good as you get on the Agilents of course, but fundamentally a very good sound piece of equipment. I've been asked to do a review on it, and while this won't be a particularly in-depth review, I will go over its basic function and show a few issues with it. That's not to say there's anything in particular that I found wrong with it. Every electronic load that I have has various issues depending on what you're trying to use it for, and it's just really bearing in mind, because of the way this type of load works, if you set it into constant current, constant voltage, constant resistance or constant power mode, they can have issues trying to track and stabilize whatever it is they're trying to achieve. So if they're trying to achieve a constant power, for example, sometimes they can fail to stabilize, and I'll give you an example of that with this particular unit. So to start with, what we'll do is we'll look at the basic operation of it. I won't go into detail with the menus. It is quite easy to use. I'll just give a very quick run through of what's in there. So very easy to access the menu, just press shift menu. There's then top line shows you the top level menu that you're in, so you've got several that you can scroll through, and as you scroll through those you'll see the option that's currently selected in the second line down. So in this case we're looking at the system menu. This is the address. You can have more than one of these on a given RS232 bus. This is computer controllable. So you set the address here that the software will use to identify it. If you want to change anything, you just scroll down, select the option you want to change, so baud rate, etc., on, off, and then when you've found the option you want to change, you just go down again, modify the setting that you want with the knob. When it's set to what you want, you just press set, and each time you press set it will back you one step further out of the menu. So the various options that you have are, as I say, for the RS232 settings, local sensing or remote sensing, so that's where it can use the remote sense terminal on the front of the unit, and then you can do a remote sense configuration where you're monitoring the voltage at the source or wherever you want to feed the voltage into the unit, rather than it measuring directly at the terminals. I'll set this to remote for this testing because I do have the remote lead connected, and the way I have this all hooked up, I have it hooked up to the Ryden supply. We have positive going out through the Agilent 34461A and then into the positive terminal of the Kunkin, and the Agilent is measuring the DC current. And then we have the Keithley, another high precision bench multimeter. Both the Keithley and the Agilent are calibrated, so they are very close to reading exactly what they should, and the Keithley has been used to measure the voltage, and it's hooked up directly to the terminals on the Ryden. So in other words, we're taking all the measurements directly from the terminal posts on the Ryden. There will be very small errors because obviously we do have resistance in the connectors, and of course that will introduce small errors at higher currents, but it will be very close and certainly good enough for what we're looking at for the Kunkin itself. In terms of specification for the electronic load, it's actually quite good. We're talking here about 0.05%, that's what's claimed anyway, plus 5 milliamps for current, same percentage plus 5 millivolts for voltage. So it's on par with a fairly good multimeter, so it claims. And then of course we have the RS232, RS485, and it has various other options that I won't go into in this review. We'll look at those possibly on another follow-up video. If you want me to look at the software and the other more involved options, then let me know. But in this video we'll just focus on the basic operation of the unit and see how well it performs. So as I say, I'll set this to remote just so that we get better performance, at least in theory. And then the various other options you have in the menu are to set. There's a battery charging, discharging, testing option. I won't be demonstrating that. But you can also set the rates on this. So if you want to set, for example, the rate at which it skews the current up and down separately, then you can adjust those, and that in theory should enable you to cause it to operate in a more stable manner depending on your system configuration. I'll leave it at the default for now, which is 200. Okay, so when you're doing a test like this, it's important to make sure that we don't have any current limiting or voltage limiting on the source supply fighting the stabilizing of the electronic load. So you will get some weird interaction between electronic loads and power supplies when you get close to the current or voltage limiting. So we want to avoid that for this test, because I'm only trying to test the electronic load here. I'm not trying to test the interaction between the electronic load and the supply. So I'll start by setting the power supply to 20 volts, 6.1 amp limit. I'll turn that on, and we can now see that the electronic load is reading 20.004 volts. Again, sorry for the flickering on the display from the load. There's nothing I can do to avoid that. It's just an artifact of my camera frame rate. So if we look now at the Keithley, we can see that the actual voltage should be 20.015016. And it ties up fairly well with the power supply, so all three are reading reasonably accurately and certainly within the specification that's been given. I'll now set the power, so we'll test the four modes of the load. We'll start with constant power. I'll set the power, and it's easy to say, you just press the set. Depending on the mode that you're in, it will then start flashing the digit that you're going to change, and it will, which it selects depends on the mode that the load is operating in. Now unfortunately you're probably not going to be able to see this very clearly on the camera due to the flickering, but what it's doing is it's flashing the digit that I'll be able to change. So in this case it's flashing the digit just to the left of the decimal point, and I can now change that with the knob. It's a very nice feel to the knob. It's got a nice click action, and what I can do is use the arrow keys to select a different column. As I say, you probably can't see it flashing, but it's now flashing the 1, and I can now modify that column. If I keep going up, it will then roll over to the next column, and if I go down, it will roll back the other way. But what it won't do is it won't then go back down to a lower column. It will only go up and down to the based on the column that you have selected. So I'll start with 10 watts. It's a live setting, so as you're making this setting, if the output was turned on, or the input, then that would be changing as you make the setting change. It doesn't wait until you press set before it introduces the new setting. So as soon as you press the set key again, the current set value goes away, and it's now the actual value that it's reading. So I'll turn the input on, and what we can see now is we're getting a current according to the adjuvant of 495 milliamps. It's fairly close to what the electronic load is reading, and reasonably close to what the Ryden is reading. The power shown on the Ryden is 9.8688, and on the electronic load it's 9.9795. So it is moving around quite a lot, and the reason for this is down to, I believe it's an issue with the firmware on the electronic load. If I get hold of one of the leads on this, you can make it stabilize, and I think it's just picking up some noise from somewhere. I think that because the way these work is they are really a switch mode supply in reverse. They are taking the input and switching it through some MOSFETs and averaging a certain power draw from the terminals, and it of course also reads the voltage and the current, and it uses that to calculate the power. Now I've got 10 watts set, but as you can see it's only reading 9.95. If I go back to setting, it's still saying 10 watts, so there seems to be something in the firmware here where I don't think it's reading the power values, the voltage and the current at quite the right time within the kind of system, and it's causing a discrepancy between the power it's reading and the power it's indicating. And you'll see this more if you play with this. You'll see that power reading doesn't really stabilize very well on the value you've set, whereas the current and the voltage do. So it seems to be taking the approach that it's trying to achieve a certain power through current and voltage, but when it's translating that into the power reading, it's not doing a very good job of it, and it's making an error. And it seems that the value shown on the ride and supply is actually closer to the actual power being fed out, and that's not because of losses in the cables. It just seems to be the way that the load is calculating the power. Okay, if we turn the power supply off, turn it back on, we can see that the electronic load stabilizes fairly quickly. However, if I change the power setting, I'll take it up to 20 watts. Again, that seems reasonably close. You can get it to change again by getting hold of the lead. So what I'm doing here is holding the cables, and you can see the value does change. So there is an element here of it picking up its own noise by the look of it. This is not caused by the noise from the ride, and by the way, I'll connect it to the Rigol in a few minutes and you'll see that does exactly the same thing. Turn the supply off, back on. Again, you can see the electronic load stabilizes, and that's fine. So I'll now change the setting again, and I'll go up to 50 watts. Again, it's stabilized quite nicely. However, if I now turn the power off, back on again, you'll see that it's now oscillating. It can't settle down, and even though I'm on the 10 amp range for the Agilent, it's showing overload, and then 5 amps, and it's up all over the place. It's the electronic load seems to be trying to draw huge currents to try to get the power up very quickly. Now, this is nothing to do with the current rate settings in the load. I've tried every setting there is within the load, and it doesn't make any difference. It just does the same thing. It just doesn't seem to be using a very sensible algorithm within the firmware for developing the current and the voltage to generate the power that's been set. And if we look at the scope, this is connected across the terminals on the electronic load, and we can see that there's a lot of very high current switching going on. This is on a 5 volt range, so this is going right up to the full range that we have set for the voltage. It's not able to stabilize, it goes off, and then it just keeps repeating that at around 50 millisecond intervals. The only way to get it to stabilize is to turn the load off and then turn it back on. So it looks like there's something again in firmware where it's not taking the proper approach to stabilizing the supply, and it's doing something very different from when you turn its own input on and off to when you do the same with the applied load. In theory it should do the same thing, but of course you can see here that it isn't. It's not a huge issue, it just means that you need to set up whatever parameter you want before you turn this on, but it does mean that if you got a load that's going to change dramatically in terms of its power, you could end up with an unstable reading from your electronic load. So for example, if I come to voltage and I change this to 10 volts, you can see we've now gone down in terms of voltage, but the current has gone up, so it's still achieving the same power setting that it should be. And if we now go back up to say 30 volts, you can see that again it stabilizes, and that's fine. The problem you'll get is if you go outside certain limits, then if you get a sudden step change, then you'll notice now that it's unstable, it can't settle down properly. And we'll go back up to a higher voltage, and again we're back now in the same situation where it's taking huge bites of current, but it's not able to settle down, and that could cause you an issue if you're trying to use this to look at a system where the voltage or current changes over quite a wide range, because obviously it won't stabilize, and you'll not only will it not stabilize, but it's trying to draw excessive amounts of current through the or from the source system. Having said that, it works fine. Now, just to prove this is not the power supply at fault, I'll just hook it up to the Rigel that's there in the background and demonstrate it doing the same thing. Okay, so I've got it connected to the Rigel now instead of the Ryden. The connections are the same, except that the power is now coming from the Rigel. The settings are the same, so 20 volts. I'll turn the power on, and you can see that the voltage is correctly showing on the electronic load. The voltage is correct on the Keithley. We'll turn the input of the electronic load on, and that's fine. And now I'll cycle the power on the Rigel, and again exactly the same problem. We're getting the electronic load oscillating, similar sort of look on the scope, slightly different profile. You can see the current spike on here is not quite as high, and that's really because the Rigel doesn't have the same current output capacity as the Ryden. And the only way to get this to stabilize is to cycle the input on the electronic load. Okay, other than that, it works reasonably well, and I would say here this may or may not be an issue. It depends on what you're trying to use the load for. We'll also say that some of the more expensive electronic loads I have do something very similar, and it does seem to depend on exactly how you have the system configured and how the power and current are applied to the load. Okay, I'll just move the connections back to the Ryden, and we'll look at the next mode on the electronic load. We'll now change the mode. We'll look at constant resistance. So I'll start by setting the constant resistance to, we'll set 50 ohms for a start, and the setting works in exactly the same way. You just select the column you want to change, use a knob to set whatever you want. The value will wrap around to the next column along, but it won't go down to the column before. So if I go below 10, for example, it won't start changing the column to the right of the decimal point. So we've got 50 ohms set. I'll change the voltage on the Ryden so we don't get the Ryden interfering with what we're doing. So I'll set that to 60 volts, 6.1 amps. I'll turn the Ryden on. You can see we now have 60.026 volts showing, and that's very close to what the Keithley is indicating. I'll turn the load on, and you can see that's stabilized quite nicely. It's reading quite close to the current the Agilent is showing, and that is also very close to the current that the Ryden is showing. Again, you can see it's fairly noisy. There does seem to be some problems with, it's either the supply or the load trying to stabilize. I suspect in this instance it's actually the supply, because I can see this if I use an actual resistor, I see something fairly similar. So I think this is just an issue with the supply itself. And again, if I take hold of the cables coming from the supply to the load, you can make it change the reading very slightly. It's a very minor effect, but you can make it change to a small degree. Again, not a big issue. As long as you get your system properly set up when you're using this, it will be fine. It's not particularly sensitive. In terms of making setting changes, it's exactly the same as we had before. you just press the set key, change to whatever you want, and then as you can see the changes come into effect as soon as you adjust them. It doesn't wait until you press the set key. That's one thing to bear in mind with this. It doesn't wait until you press the set key. As soon as you start changing this, you'll see that the current changes and also the current coming from the supply changes. So it is an immediate change in response and does not wait for you to press the set key. I actually quite like that. It means you can cycle it through quite quickly to do various testing. Okay, so that works quite well. We'll turn the supply off, turn it back on. That stabilizes quite well, but this will do something similar to the constant power setting depending on the resistance that you have set. And again, notice that when we press set, instead of it selecting the power to be adjusted, it's now changed the symbol for current to ohms, and it's allowing us to change the resistance directly. It does that automatically. It's quite a nice feature. The interface on this is very nice. It's very intuitive to use and very simple and quick to use. I can't say the same about the menus. They are quite difficult to read, but the manual does make it clear what each one is for. One thing I don't really like about it, and it makes me feel a bit uneasy, I'm a systems developer, and now and again I'll see various LEDs flickering on the display on this. There's so one there. I don't know if you can see it on camera. That does concern me a little bit from a systems perspective. It's not something it should be doing, and it does indicate that there are maybe some issues with the firmware that need to be resolved. But so far it hasn't crashed or done anything particularly weird. So as I say, you can change this quickly and easily. It seems reasonably stable most of the time. There are various modes you can put it into where it will possibly become unstable, as it did with the power. So we've now got it set to quite a high power, but even so it stabilizes quite nicely, and the values we're seeing on the display are very close to what the Agilent and the Keithley are reading. It's within a few millivolts and a few milliamps. So that's constant resistance. We'll now try the next mode, constant current. So again, when we press set, because it's in constant current mode, although it's the middle display flashing again, notice instead of it showing ohms, it's showing amps, and we can change that down to the nearest milliamp. So if we want to change milliamp at a time, we can do that. So it does seem to have a reasonably good resolution, and this does seem to work. You'll see we're reading something fairly close to 5 amps, and as I change this, you'll see that the current does go up in response in milliamp steps. So it does appear that this does have a true resolution of 1 milliamp. I don't think there's any gaps in the resolution at all, but so far I haven't seen it skip anything. So we've got it stabilized. It's reading again nice and close to what the Keithley and the Agilent are showing. If we turn the supply off and back on, stabilizes nicely. We'll change the current, try a few different values, but this seems to be reasonably stable. I'll take it down to 1 amp. Cycle the power, and it stabilizes quite quickly. So the main issue with the stability just seemed to be in the constant power mode, and I think it's because it's giving a resultant power rather than directly trying to control the power. So now we'll look at constant voltage mode. Change the mode, constant voltage. We've got CV shown on the display. It's set to 15 volts, and again notice that it automatically selects the correct parameter to change based on the mode you've got it set into. Set on 15 volts, we'll leave it on that for now. We'll turn on the load, and sure enough we're getting 15 volts, or very close to 15 volts. Now I've got this set to read remotely, so in other words I'm using this remote input to the load. So if we look back in the menu, you'll see that I've got this set to remote, which means we're monitoring the voltage directly at the terminal. So if I disconnect this, we should see that the actual voltage on the Keithley and on the power supply should change, because the electronic load will carry on reading 15 volts, but it will now be reading 15 volts from the local terminals rather than these terminals. So there should be a step change in this voltage. So I disconnect this. Sure enough, we're seeing quite a big step change. Electronic load is of course still reading 15 volts because it's limiting itself to 15 volts, and because I've disconnected this, it looks like it defaults back to reading locally on the load itself, which is quite a nice feature. It doesn't start doing ridiculous things if this wire comes loose. So if I reconnect this, this should drop back down, as should the voltage on the Raiden, because the electronic load will now be trying to control the voltage at this terminal rather than at these terminals. So I'll reconnect that, and sure enough the voltage has gone back down. So the remote sense feature seems to work, and I have tried this. I've tried transferring the meter to these terminals, and it does read accurately whether you got remote connected or local. So the remote sense feature does seem to behave the way that you would expect it to. Okay, we'll try cycling the supply to make sure it's stable in this mode. Now, someone left a comment about the Raiden on a previous video. Extremely good comment, saying that the Raiden would benefit from having a power relay between the output terminals and the internal supply, and that's absolutely correct. One of the main problems with the Raiden, it's got a lot of capacitance on the output, and you can really see that here with no real load set on the electronic load. If we turn the input to the load off, it's just now reading the voltage. If I now turn off the power supply, you can see how slowly this voltage drops as the capacitors inside the Raiden discharge. That's not a fault with the electronic load, of course, that's just down to the Raiden itself. It's just something to bear in mind, that if you disconnect the Raiden and there's a high voltage on the output, that will still be there even if you turn the output off, and you might come back to it a minute later and it might still be quite a high voltage there, so just bear that in mind. Okay, so as we can see, the electronic load can stabilize quite nicely. We'll change the setting for the constant voltage, so I'll take it up to 30 volts. We'll turn the load back on, and that stabilizes quite nicely. I'll cycle the power, and again it stabilizes quite nicely. So overall its performance is very good. It does seem to stabilize and behave itself mostly. The only times I've had an issue is in constant power mode. So if you are doing something on a circuit where there is a lot of variation in the voltage or current that your circuit is using, I'd recommend you leave this in constant voltage, constant resistance, or constant current mode. Constant power mode may well cause you some issues. Incidentally, you probably noticed I've turned the beeper off on this. It's too loud, it's very annoying, so you can turn that off. Okay, so that's it for this video. I'm still happy with the purchase. The testing is going fairly well. The only thing I've found with it so far, as I've said, is the issue with the constant power. It does seem to be unstable under some conditions. The only other feature I don't like about this is the power switch is on the back. So once this is in the rack on my bench, I won't be able to turn it on and off without pulling it out, and that's a little bit irritating. There's no real proper standby mode that I can find, and it does mean that it's constantly powered up, and it does draw quite a lot of power even in its sort of default state when it's not actually active. But other than that, that's a minor issue. I can just power the bench remotely, but it would be nicer if the power switch was accessible on the front. If you want me to go over this in any more detail, then let me know. But as I say, so far it's worth the money and should do the job I want it to.